Hi guys, welcome back. It's Mr. Mustafa here. We are solving the Class 10 Bihar State Examination Board Advanced Mathematics 2021 model paper. I am providing you with full solutions with explanation. Please don't forget to like and subscribe my video, and don't forget to comment on this video. Before I start with these long type of questions, I want to go back to question number 129, and I said there was an error in the question, but because I've read it as a negative, it should not be a negative. Question number 20. Is this question here? Yes, this question number 29. So remember what I've said was, choose a different color. I've read it as a negative. So if you omit the negative and if you write it as sine 40, which is sine 30 plus. So if you take out the negative and just deal with these things here, with these. So if I say this is sine 30 cos 10 plus cos 30 sine of 10 degrees plus sine 30 cos 10 minus cos 30 sine 10 degrees. So if we add up these two, this and this cancels out. So we are left with 2 sine 30 degrees cos 10. And then what is sine of 30? Sine of 30 is half. 2 into half into cos 10. So 2 times half cancels out. So we are left with cos of 10 degrees, which is equal to right hand side. So which was actually correct. So see, I read it as a negative, so I ended up saying it wasn't equal to, but without the negative, it is equal to cos 10, right? So this is without the negative, there's no negative here, right? So sine 40, so therefore, what we know is sine 40 plus sine 20 degrees is equal to cos of 10 degrees. This is the proof. So coming back to the long type of question, question number 31. See, these are 4 marks each. So question number 31 says a tower stands vertically on the ground. So we need to draw a diagram here. So here's the tower. T stands vertically on the ground from a point on the ground which is 15 meters away from the foot of the, so there's a foot of the tower. If, oh sorry, that's the foot of the tower there, and this is a point. So from a point on the ground which is 15 meters away, so from the point on the, which is 15 meters away from the foot of the tower, so this is 15 meters, the angle of elevation. So if you are here and if you're looking up, the angle of elevation is upwards of the top of the tower is 60 degrees, right? That's 90. So we want to find the height of the tower. So this is the height. Now to find the height, we need to look at the trigonometric ratio. So looking at the solution, which is tan of 60 degrees, which is equal to h over 15. So which is opposite over adjacent. So h is equal to 15 tan 60 degrees, which is equal to 15. Tan of 60, if you're looking at tan of 60, there's 60 degrees here, which is root 3. So my solution is 15 root 3. Looking at the next question, which is question number 32. What is question number 32? Cool. So question number 32 says, prove that. So what I can say here is left-hand side. Left-hand side is equal to cos 4 theta, cos 2 theta. That's half angle, which is cos should give me cos A minus B plus cos A plus B. So let's do the plus cos 4 theta plus 2 theta plus cos 4 theta minus 2 theta. Subtract. And same story here. Cos 6 theta. Let's put it back in there. Minus, what we can say here is cos of 6 theta cos of 6 theta plus 12 theta minus, sorry, plus cos of 6 theta minus 12 theta. So which is equal to half. That was a half there, half here also. So half into cos 6 theta plus cos 2 theta minus half into cos 18 theta plus cos 6 theta, which is negative 6 theta, which is equal to cos of 6 theta. So we can see we have half cos 6 theta half cos 6 theta. You can see half, let's do this, let's just expand it like this, half cos theta plus half cos 2 theta minus half cos 18 theta minus half cos 6 theta. This one and this one cancels out. What we are left with is half into cos 2 theta minus cos 18 theta. Which is equal to half cos 2 theta minus half into cos of 18 theta. We can break it down in terms of cos of 10 theta plus 8 theta, which is equal to half cos 2 theta minus half into cos 10 theta cos 8 theta minus sine 10 theta sine 8 theta, which is equal to so we have sine 10 theta sine 8 theta in here, sine 10 theta sine 8 theta in here, and this is cos 10 theta cos 8 theta, and this is half cos 2 theta. So I'm sure we can do something here. which is cos 10 theta, cos 8 theta. Let us use half angle again. Half cos 2 theta minus half into half cos 2 theta plus, that's 10 minus 8, cos 18 theta again. Okay, looks like we're going in circles here, guys, because ended up with 18 theta again. So let's try another technique. Okay, so it looks like we're going in circles here because we ended up with cos 18 theta. So let us try out another strategy here. Let's take this out and work with this. So we know what the expansion for sine x sine y is, which is equal to half into cos x minus y minus cos x plus y. So if you are looking at this, what we can say is, remember what we can say, x minus y is equal to 2 theta. No theta here, let's just say x minus y is equal to 2, and x plus y is equal to 18. How I've got that? Because if you go scroll up here, we got half cos 2 theta minus cos 18 theta. So what we have here is, remember what we have is cos 2 theta minus cos 18 theta. So what we actually have here is, if we add both up, we get 2x is equal to 20. Therefore, x is equal to 10. So y will be equal to 8 because x is 10. 10 plus 8 is 18. So guys, yes, we are writing here cos of 18 theta. So this x minus y can be represented as cos of x is, which is 10 theta minus, so that can be written as, since x is 10, y is 8, what we can say is that half into cos of 10 theta minus 8 theta minus cos of 10 theta plus 8 theta is actually just equal to sine 10 theta sine 8 theta, which is equal to the right hand side. Let's see. So what we had here, half. So what we have done here on the left hand side was we used half angle for the first part and a half angle for the second part. And just zoom out from there. So what we said was, on the left hand side, cos 4 theta, we used half angle here, so we ended up with this entire thing. Then we said minus cos 6 theta times cos 12 theta, we ended up with this using half angle. So final simplification of half into cos 2 theta minus cos 18 theta, and this is actually equal to sine 10 theta sine 8 theta. How? Like the sine x sine y is equal to half into cos x minus y minus cos x plus y. Using this formula, we ended up with sine 10 theta sine 8 theta. Now looking at question number 33. Question number 33 says tan alpha is equal to m over m plus 1. So tan of alpha is m over m plus 1, and tan of, so the hypotenuse will be the square root of m squared plus 2m plus m plus 2m plus 1 plus 2m squared. Okay, let's just write it like this. Do we need the hypotenuse? Let's see. We don't actually need, let's see if we need the hypotenuse. Right, so tan alpha is m over m plus 1, tan beta, tan of beta is equal to 1 over 2m, 1 over 1, 1 over 2m plus 1. Now we want to prove that alpha plus beta is equal to 45 degrees. Right, so in order to prove alpha plus beta is equal to pi by 4, which is 45 degrees, we can just say that use the expansion for tan of alpha plus beta, which is tan alpha plus tan beta over 1 minus tan alpha tan beta. Tan alpha is m over m plus 1 plus 1 over 2m plus 1 divided by 1 minus m over m plus 1 into 1 over 2m plus 1. Now simplifying this should simplify, which is equal to m into 2m plus 1 plus m plus 1 over m plus 1 into 2m plus 1 times m plus 1 into 2m plus 1. Oh, this is for this part, over the numerator comes down. This is the denominator, goes to the top because we are dividing. Okay, if we just say this divided by, then this will go down, switch it around. So what you can say is m plus 1 into 2m plus 1, and the top will be m plus 1 into 2m plus 1 minus m, which is equal to 2m squared plus, simplifying this, 2m squared plus m plus 1 over m plus 1 2m plus 1 times m plus 1 2m plus 1 over 2m squared over 2m squared plus 3m plus 3m plus 1 minus m. You can see that, and that cancels out. We are left with 2m squared plus 2m plus 1 over 2m squared plus 2m plus 1. That cancels out. The answer is equal to 1. But what is equal to 1? Tan alpha plus beta. This implies alpha plus beta is equal to 45 degrees, which implies alpha plus beta is equal to pi by 4. Next question, guys. Question number 34 says, find the equation of the straight line which is parallel to the line. Just going back, Alpha plus beta is equal to pi by 4. That's what we needed to prove here. See that? Alpha plus beta is equal to pi by 4, which is correct. So let us get back to question 34. Find the equation of the straight line which is parallel to the line x plus 2y. So because it says parallel, equal gradients, and if the gradients are equal, we have y is equal to minus x over 2 plus 3 over 2, looking at this equation coming there. Therefore, m is equal to minus half. Therefore, parallel gradient is also equal to minus half. And we have a point here, 3, 4. Therefore, y is equal to minus half x plus c at 3, 4. 4 is equal to minus half times 3 plus c, which is equal to, c is equal to 4 plus 3 over 2. 4 is 8 over 2 plus 3 over 2, which is, therefore c, let's just write it like this. C is equal to over 2, 8 plus 3, which is equal to 11 over 2. Therefore, y is equal to minus half x plus 11 over 2 is the answer. Question number 35. We want to find if cosec A plus sec A equals cosec B plus sec B, then prove that tan A tan B equals cot A plus B over 2. To prove this, we can say, let us start with this, then prove. So we have to use this to prove this. So therefore, cosec A plus sec A is equal to cosec B plus sec B. Cosec A is 1 over sine A plus 1 over cos A, 1 over sine B plus 1 over cos B. And rewrite it as collect all the sines on one side and all the cos on one side. 1 over sine A algebra minus sine B is equal to 1 over cos B minus 1 over cos A, which is equal to, so we just took this cos and cos, collect it on one side, and sine, take it across. So what we have here is sine B minus sine A over sine A sine B is equal to cos A minus cos B over cos A cos B. Taking this over and bringing this down here, we have sine B minus sine A over cos A minus cos B is equal to sine A sine B over cos A cos B. So guys, what we're coming to across here is, just need to do a little bit of algebra to get this right. So we can see we need to get tan A, tan B. I've got tan A, tan B. Can you see here? So on this side, I already have tan A, tan B. How? Collecting this and this one here, tan A, tan B. Okay, so let me just take this one out. Right, tan A, tan B. Now, on this side, we need to prove that this here is actually equal to cot A plus B over 2. So what we know from the formula is sine B minus sine A is 2 times the half angle formula, guys. So sine B minus sine A is 2 times cos of A plus B over 2 times sine of B minus A over 2 all over minus 2, and no need to write this, it's 2 times, so minus 2 sine, for cos, you're just going to get sine of A minus B over 2 and sine of A plus B over 2, sine of A plus B over 2. Now you can see that if you reverse this, take out a negative, let me just change the color of the pen. So what I was saying was that if you take out a negative here, because we need to cancel out the 2's with the negative, so what we can say is 2 cos A plus B over 2, the minus of course sine of A minus B over 2 all over minus 2 sine A plus B over 2 sine A minus B over 2. So this one and this one cancel out, minus 2 cancel. Cos over sine is cot of A plus B over 2, which is equal to tan A, tan B. Hence proved. Let us see. Cot of A plus B over 2 is equal to tan A times tan B. So what we need to do is use the original information. They said if then. So use the if to prove the result. Looking at question number 36. Prove that 1 plus tan A times tan A over 2 is equal to sec A. So what we can do is, what we know is that tan 2 times A over 2 for tan A. So let's just say tan A is equal to 2 times. So it is 2 tan A over 2 divided by 1 minus tan squared A. Right, so left hand side, let's just say that 1 is equal to 1 plus 2 tan A over 2 over 1 minus tan squared A over 2 times, what is tan of A over 2? Now let's just write it as tan of A over 2. which is equal to, now we need a relationship between 1 minus tan squared. So what is 1 minus tan squared? So what we know is sine squared A plus cos squared A is equal to 1. 1 minus tan squared, divide everything by cos squared. So I'm getting plus 1 tan squared is equal to sec squared A. So if I say 1 minus tan squared, we know that sec squared A minus tan squared A is equal to 1. So if I replace the 1 with sec squared A minus tan squared A, I will get, no, so let's just keep it as 1 minus tan squared A. We know that tan squared A plus 1 is sec squared A. So what we can do on top is simplify this. So we can say 1 minus tan squared A plus 2 tan squared A over 1 minus tan squared A, which is equal to 1 plus tan squared A over 1 minus tan squared A. And this is A over 2, A over 2, A over 2, A over 2, A over 2. Okay, guys, looks like, hi guys, looks like we are going in circles again with this. If you can find a way to prove this, please comment. Right, please comment. Right now, I'm just looking at that identity. I should have just used the traditional method here, which is the expansion for tan sine over cos and tan over 2 as sine. Right, so let us just look at that alternative method. So I'm going to take this out a bit. So coming back to question number 36, remember we tried the other method where we used the expansion of for tan 2 times a over 2, and it was quite difficult to do it in that manner. So let us try the traditional way, which is much more easier. So 1 plus tan a, looking at what we can say is, remember, tan of a is equal to sine a over cos a, which is sine of 2 times a over 2 over cos of 2 times a over 2. This would have been much more easier. So you can say 1 plus sine of 2 times a over 2 over cos of 2 times a over 2 times sine a over 2 cos a over 2, which is equal to 1 plus sine 2 times a over 2 is 2 sine a cos a divided by cos squared a minus sine squared a. I suggest let us just leave this denominator as it is, which is cos 2 times a over 2 cos 2 times a over 2 times sine a of a over 2 divided by cos of a over 2. Cos of a over 2 and cos of a over 2 cancels out. So you got 1 plus 2 sine a over 2 divided by cos of sine squared a over 2 divided by cos of 2 times a over 2, which is equal to what do we need to find? We need to find that that is equal to sec a. So what we can say here is, oh yes, for the denominator, that's 1 over 1. This here is actually equal to cos squared a minus sine squared. Okay, let me write it as 1 minus 2 sine squared a. Will be easier. The reason why I'm writing like that, because we have 2 sine squared a over 2. So we can write it as 1 minus 2 sine squared a over 2. And remember, this is also equal to cos of a. Don't forget that. So 1 minus 2 sine squared a over 2 plus 2 sine squared a over 2. This one and this one cancel out. We got 1 over cos a, which is equal to sec a. So hence proved. Now guys, looking at question number 37. Alright, question number 37 says cos a over a plus cos b over b plus cos of c over c is equal to a squared plus b squared plus c squared over 2abc. Okay, so we can just use the cosine rule, which is left hand side is equal to 1 over a into, so this should be 1 over a into b squared plus c squared minus a squared over 2bc plus half into, 1 over b into, let's just change this, that's 1 over b, I'm writing it as 1 over a, 1 over b into minus b squared goes there, a squared plus c squared over 2ac plus 1 over c into minus c squared, a squared plus b squared over 2ab. What we can see now in the denominator is we have 2bca, 2abc, 2abc, 2abc. So same denominator throughout. So we got 2abc. On the top we got b squared minus b squared cancelling out. We have c squared plus c squared, which is 2c squared. So we've got b squared plus c squared minus a squared plus a squared plus c squared. You can see that and that cancel out, plus c squared minus b squared plus a squared plus b squared, that one cancelling out, minus c squared, that one cancelling out. So what we just have is equal to a squared plus b squared plus c squared over 2abc. We just change that over 2abc, and that's what we need to prove here. A squared plus b squared plus c squared over 2abc. Last question, question number 38. Find the area of the triangle ABC if its vertices are. So I like to draw this, not to scale, just to have a picture of what we're looking at. 2 and 1. I'm just estimating 2, 1. This is A here, which is 2 and 1. B is minus 3, 7. Minus 3 and 7, somewhere around there is B. And C is minus 4, 5. Minus 4, 5. Minus 4, 5. This is C. So we're looking at a triangle which is something like this. Oh, joining up there. So does not even look like a triangle here. Right. So what we can say is that, right, so directly opposite is A, B, and C. Right, so if you're finding A squared is equal to, A is equal to, using the distance formula. Right, to solve this, to find the area of the triangle, we are going to use Heron's formula, where we don't need the angles, right? So in Heron's formula, what we know is, we know A plus B plus C over 2 is equal to S, and area of the triangle is equal to square root of S into S minus A, S minus B into S minus C. Now we need to go and find what is ABC. So A is equal to, so we know what A is equal to. Let me write here. So A is equal to square root of, A is equal to square root of, so we are finding the distance BC, which is A, and B was minus 3, 7. B was minus 3, 7, right? So what we can say is A is equal to minus 4, minus 4 minus minus 3 minus 4 plus 1 all squared plus 5 minus 7 all squared, which is equal to square root of, it's too big here, which is equal to the square root of, so this will give us 9 plus 4, which is square root of 13. To find B, which is square root of, B is actually finding AC. So what are you going to say? Minus 4 minus 2 all squared. Minus 4 minus 2 all squared plus 5 minus 1 all squared. 5 minus 1 all squared. So we're getting 6 squared, which is 36 plus 4 squared, which is 16. So which is equal to square root of 52. Square root of 52, which is 4 times 13. So 2 root 13. And then C is equal to square root of. To find C, we're looking at BC. So 2 plus 3 all squared plus 7 minus 1 all squared, which is equal to square root of minus 3 minus 2, which is, 2 plus 3 and 1 minus 7. We took that coordinate A first. So 2 minus minus 3 is 2 plus 3 and 1 minus 7. All right, so what we have here is 25 plus 36, which is equal to square root of 6 and 5 gives me 1. and square root of 61. 25 plus 36 is equal to square root of 61. Therefore, S is equal to root 13 plus 2 root 13 plus square root of 61 over 2, which is equal to 3 root 13 plus square root of 61 over 2. Square root of 61 can be written as, no, square root of 61 is irrational. Square root of 61. So what we can say here is, what is S minus A? So this entire thing is S. S minus A will be 3 root 13 minus plus square root of 61, which is S minus A is equal to over 2. Subtract, this is S minus A. A is, what is A? Root 13. I like to write it as 2 root 13 over 2 root 13. 2 root 13 over 2. Same denominator, which is equal to root 13 plus square root of 61 over 2. That's what S minus A is. We know what S is. Then what is S minus B? S minus B is equal to, we need to subtract 2 root 13 from there. So you got 3 root 13 plus square root of 61 over 2 minus 4 root 13 over 2, which is 2 root 13. So what we're getting here is equal to negative square root of 13 plus root 61 over 2. And we can see multiplying these two will give me an answer of, if I have to multiply these two out, I will get an answer of 61 minus 13 over 4. We can see difference of two squares, square root of 61 plus 13, square root of 61 minus 13. And 61 minus 13 is 48 divided by 4, which is giving me 12. Gives me 12. So what we can say here is, and then the final one we need to find is S minus C, which is S minus C, which is 3 root 13 plus square root of 61 over 2 minus C, which is square root of 61 minus square root of 61, 2 root 61 over 2. So I'm getting 3 root 13 minus square root of 61 over 2. And what we can see is that, remember, we found the value of this, which is equal to 12. Now, if I have to multiply S and S minus C, look at these two. The product of S and S minus C, I'm going to get, sorry, this was product of, remember this here was the product of, that was product of S minus A into S minus B. Now what we're doing is product of S into S minus C, which is equal to, we can identify this one and this one as difference of two squares again, which is 3 root 13. I will get 9 into 13 minus 61 over 4, which is 9 times 13. 9 times 13 will give me 117, minus 61 will give me 56 divided by 4. 56, and if I have to divide it by 4, I will get 14. Therefore, area of the triangle is square root of 14 times 12, which is equal to 14 times 12, which is equal to square root of 2 times 7 times 2, 4 times 3. Let's write it as 4 times 3. Using prime factorization, which is equal to, we only have square root of 4 there, which is 2 root 2 times 7 is 14 times 3 is 42. I'm getting an answer of 2 root 42. Right, for this question, if you have an easier method, please comment. Right, so guys, this brings us to the end of a video series solving the Advanced Maths 2021. So don't forget to like and subscribe to my video. Subscribe. And if you want to contact, you can also contact me. If you have some amazing questions, contact me on my contact number, +27 74 613 8888, all the way from South Africa. Thank you. Have a good day.